Hello everyone. Okay, so in this video we are looking at the integrals of trigonometric functions. So we're going to look at the basic integration of trig functions, and then also we're going to be looking at examples where we have to use trig identities. So first of all, here's just our rules of integration. So what we know is sine goes to cosine when we differentiate, and cosine goes to minus sine when we differentiate. So when we're integrating, sine is going to go to minus cosine, and cosine is just going to go to sine. So what we do is, right, so sine goes to minus cosine, and then you divide by the derivative of the angle. So you make sure you do that, and then divide by the derivative of the angle. So let's have a look here. I am integrating cosine 5x minus sine 2x between 0 and pi. Cosine goes to sine, so this becomes sine 5x. Divide by the derivative of the angle, which is 5, minus then minus then sine goes to minus cosine, so be minus cosine 2x divided by the derivative of 2x, which is 2. Now I'm evaluating this between pi and 0. So this becomes sine 5 pi over 5 plus cosine 2 pi over 2 minus sine 5 times 0 over 5 plus cosine 2 times 0 over 2, which is equal to 0 plus a half minus 0 plus a half, which will just be equal to 0. So the answer there will just be 0, the integral between them two there. Right. Let's have a look at some questions here. So 2024, find now the integral of cosine 6 of x. So this is an indefinite integral, so we need to remember to add the plus c. So this cosine goes to sine. So it's sine 6x divided by 6 plus c, right? 2014, 5 cosine 3x, well, that would be 5 sine 3x divided by 3 plus c, divided by the derivative of the angle, right? What about here? Sine 2x plus e to the 4x. So that will be minus cosine 2x divided by 2. Then e to the 4x will just be e to the 4x divided by 4 plus c. There is my answers there. Now, the trickier ones we can get is we have to use trig identities, right, to help us. So I'm looking at this one here. I'm integrating sine x times cosine x between 2 pi and pi over 2. Now, problem is, like I said, right? Like I said, we do not have a product or quotient rule or anything like that in integration in leaving cert, right? So we need to look at then my trig identities and see which any of them help. So these are in your log tables. So I'm looking here, right? I am looking to change like the product to like the product to a sum or C. So when I was looking through the tables, I saw this one. 2 sine A cosine A is equal to sine 2A. Well, that helps because these two are the same angle here. So 2 sine x cosine x is equal to sine 2x. And I just have sine x cosine x. So sine x cosine x is going to be equal to sine 2x divided by 2. So therefore, I can rewrite sine x cosine x as sine 2x over 2. Now I'm integrating between 2 pi over 2, sine 2x over 2. The integral of sine is minus cosine, so it's minus cosine 2x divided by now the derivative of the angle, which is 2. So it'd be 2. So I'd be multiplying then the bottom here by 2, so it'd be 4 here. And then now I'm integrating that between 2 pi and pi over 2. So that is minus cosine 2 times 2 pi, which is 4 pi, over 4, minus cosine 2x times pi over 2 is pi, over 4, which is equal to, make sure your calculator is in radians, because we're dealing with pi. So it is minus cosine 4 pi over 4 minus the ding, minus cosine pi over 4. And my answer here will be negative a half when I put that in my calculator there. Okay, let's have a look at some examples here. So here are some trig identities, and we need to figure these out. So again, cosine x squared. It's again, we don't have a chain rule. We don't have a chain rule in leaving cert integration. So I need to find a way of rewriting cosine squared. So I'm kind of looking here, I'm looking around, and like I see, well, cosine 2a is equal to 2 cosine squared a. So I'm thinking here, cosine 2a equals 2 cosine squared a minus 1. So it would be cosine 2a minus 1 equals 2 cosine squared a, divide by 2. There, so I can rewrite cosine squared a as cosine 2a over 2 minus a half. And I'm integrating this. Cosine goes to sine, so it'll be sine 2a, divide by 2. So 2 times 2 is 4. And then minus a half x. Well, so it was x here anyway. So a is an x. And plus c. There's my answer there. Right. Now I have here 2 sine 2x cosine 2x when I'm looking here. And I see, well, these are the same angles. So let me see. Oh, I can rewrite that as sine 2 of the angle. So this can be written as sine 2 times 2x. So sine 4x. And that can be written as minus cosine 4x divided by 4 plus c. This one here now, 2 cosine 5x, cosine 3x. Right, so I'm multiplying 2 cosines together. So let me see here. Well, I can change it now here. So 2 cosine a cosine b is cosine a minus b plus cosine a plus b. So 2 cosine a cosine b. So this equals 2 cosine a minus b, 5x minus 3x is 2x, plus cosine a plus b. So again, just a reminder, I'm using this one here. A plus b, 5x plus 3x is 8x. So I'm integrating this between pi over 3 and pi over 6. So it's going to be sine 2x over 2 plus sine 8x over 8. And I'm integrating between them two there. So as I was saying, oopsie. Okay. So as I was saying, I could use my calculator for this one if you weren't too bothered. So let me define my function here. Define my function. So my function is sine 2x over 2 plus sine 8x, close the bracket there, all over 8. Now, I need to evaluate. So f of my upper bound, which is pi over 3, minus f of pi over 6 execute that, and my answer here then will be root 3 over 8. And finally, last one here, but this last one's an easy one. because what I see here is sine, let me get rid of that there, sine squared t plus cosine squared t is integrate that. Well, sine squared plus cosine squared is 1. So now I'm actually just finding the integral of 1 with respect to t. The answer will just be t plus c. And that is my final answer there. Right. I hope this video was some help to you guys. And I'll catch you guys later. Bye.